Welcome to the deep dive. Today we are really getting into the weeds, looking at something fundamental. Lightning Web Components LifeCycle hooks. These are, basically the key methods controlling your component's life, from creation right through to deletion.
Exactly. And, understanding how these work and when they work is just essential. We're talking efficiency, managing state properly, fetching data at the right time, and crucially, preventing those nasty memory leaks. Get this wrong and your app can really suffer.
Right. So our mission today is simple. Map out that journey. We'll track a component through its 5 core stages, highlighting what to do, and maybe more importantly, what not to do. Okay, let's start at the absolute beginning. Creation. The constructor. This is square one. The instance is just being created in memory. And rule number 1 right off the bat.
Super. You have to call super. First thing you do, period.
But hang on, if it runs first, why not just grab the component's elements then?
Oh, yeah. Yeah, see, that's the classic trap. The component instance exists, sure, but LWC hasn't actually plugged it into the page, into the DOM yet. So no this.template access here, no DOM queries. It's really just for basic property setup. Simple stuff.
Okay, so initialization happens, then it gets added to the page. It's the connected callback, right?
Yeah.
The component sort of on-stage moment.
Precisely. It's now officially in the DOM. And this is your prime spot for those one-time setup tasks. Think firing off an Apex call to get initial data, maybe subscribing to a message channel, setting up a timer, that kind of thing. Do it once, do it here.
Got it. So from insertion, we move into this loop phase, the rendered callback. You mentioned this one's different because it fires multiple times.
Yeah, multiple times. That's the defining feature. Every single time a public property changes or any internal state that's reactive shifts, bang, rendered callback fires again after the re-render happens.
Which makes it the place for DOM interaction.
Exactly. Because it runs after the render, you have that guarantee. The elements you want to maybe measure or interact with directly, they are definitely there. It's the safest point for that kind of work.
Okay, powerful, but sounds like there's a catch. What's the big warning sign here?
Oh, the infinite loop. It's almost a rite of passage. If you set a reactive property inside rendered callback, well, think about it. You change the property, that triggers a re-render, which triggers rendered callback again, which changes the property, and boom, your browser freezes.
Right, not fun. So how do you avoid that death spiral?
You need a guard, almost always. A simple Boolean flag, like this, has rendered initialized to false. Inside rendered callback, you check the flag. If it's false, you run your complex DOM logic, then set the flag to true. So it only runs once, or only when some specific condition you control is met. Protects you from that loop.
Makes sense. Okay, so the component lives, it updates, eventually it has to go. That brings us to disconnected callback, the cleanup crew.
Cleanup crew is a perfect way to put it. When the component gets removed from the DOM, this hook fires, and it is absolutely critical for preventing memory leaks. Anything you started or subscribed to in connected callback, you undo it here. Unsubscribe from listeners, clear your intervals, stop your timeouts. If you don't, that stuff just hangs around in memory, slowing everything down over time. Really important.
Okay, essential cleanup, and there's one more, right? A sort of safety net. Error callback.
Yep, error callback, error stack. Think of it like an error boundary, but specifically for LWCs. Its job is to catch JavaScript errors that happen downstream in any child components nested inside the component that has the error callback.
So not errors in the component itself, but in its children.
Correct. It catches those child errors, lets you log the error and stack details, maybe show a nice fallback message to the user. Instead of letting that one broken child component crash, that whole section of the UI, it contains the blast radius.
Okay, that's a lot to track. So boiling it down, the typical flow is constructor for basic creation. Then connected callback when it hits the DOM for setup.
Right, the one-time stuff.
Then rendered callback firing after every render for DOM work, carefully guarded.
Yep, watch that loop.
And finally, disconnected callback for cleanup when it's removed.
Nailed it. That's the core life cycle.
So mastering that flow is key to stable components.
Absolutely. But here's something to really think about for you listening. We talked about that infinite loop trap in rendered callback. But imagine more complex UI scenarios. What if you need to synchronize animations between multiple child components after they've all rendered? Or perform complex calculations based on the final render dimensions of several elements? Without that rendered callback guarantee that everything is actually rendered, how would you even begin to tackle those reliably? Makes you appreciate why it exists, right?
Okay.